this is fun. We're on the home stretch, right before lunch, the third day. Just a quick show of hands so I get a sense of who we're talking to. I'm going to ask if you can kind of roughly identify into one of 3 or 4 groups. I'm going to ask if you're an academic, if you're not. You got to hear what the options are before you vote. Good to know. Are you an academic? Are you kind of a nonprofit? Or are you kind of on the commercial side? Now, I know that there's like ambiguity and there's space in between, but for this thing, just kind of pick one so we get a rough sense of who's here. So academic or scientist, what do we have? All right, so maybe give or take a third. Nonprofit, conservationist, give or take a third. Commercial, private. Okay, they all sit in the back. That's very telling. But wait, I know, I recognize them. They're the like half nonprofit or half, they're a mixture of the other ones, so. All right, so good, it's a friendly crowd. Everybody kind of knows each other here. And so what we want to talk today is about some of the work that Google's been doing with partners to really try to bring solutions to this space of climate risk. And some of the topics that we want to talk around here are like products that have been fully built, and we're really trying to sell into a space to allow companies and other market forces to take advantage of these things that we're seeing in a changing world. And then we're also going to have another group that's going to talk a bit about kind of that process of how do we move from an academic world into an operational one so we can leverage the private sector for the change that we all see and believe we need here. And so there's 2 major groups that are speaking up here. I'm filling in on 2 sides, both as a Googler that's been on the Earth Engine team for well over 10 years, but also as somebody that's been working very closely with Climate Engine's team, which makes a product called SpatiaFi. So we have myself, we have Keiko, who's been a long-term person in this community. She's the director of science for Climate Engine. And then we have Spatial Informatics Group that, again, has been a long-term partner, working a lot with NASA Severe and other groups like FAO. But now they're trending into the commercial space as we try to bring these products forward. And then finally, Karis, who's leading their director of environmental mapping. So I'm going to kick this off, and I am temporarily putting off my Googler hat and putting on one as a Climate Engine partner manager that I work very closely with, and showcasing some of the work that they've developed building on Earth Engine and other GCP products. Just on timing. So we don't have to spend a lot of time talking about this for a group like this, but the planet's changing at an unprecedented rate. We're seeing these drastic changes, the highest levels of CO2 we've ever experienced in that way. We're seeing massive biodiversity loss. How do we put this information in the hands of businesses so they can make decisions? And when we look at kind of fundamental businesses, there's really no area that people can really be in today where they feel they're not going to be affected by climate change. We have a few examples up here. When Tesla wanted to open a new plant in Germany, they found out the electricity demands were going to be a huge issue. They weren't sure how to work on that. The example around microchips, something that used to be kind of very tech-focused, for saying if you don't have enough clean water nearby to work through that process, that's going to be a challenge for manufacturing. So as droughts and other things come, this is affecting all areas of it. We've all seen kind of the local fires, floods, other extreme weather events. We're only seeing more and more of this, and businesses have to be adapting for this. And so what Climate Engine's kind of done is they've gone off and said, looking at these key things that are shifting that entire industry, let's put that information in the hands of others to help make decisions. And so when we look at SpatiaFi, what they've really come up with is that they want the most comprehensive economic early warning system to predict the financial impacts of planetary change. And so traditionally, when large weather events like this happen, it's a game of how much insurance did you buy beforehand, and will that cover your losses? And it's generally a retrospective piece. But how can we be more actively planning about the risks that each area is facing and be able to make decisions on this as they're coming in advance? And so there's basically 3 pieces that are coming together. One is our location data. We have to know where the assets are that we care about or we are dependent on. So that could be where your manufacturing plant is. It could be where your office is. It could be further down in your supply chain for people that are leading other components there. If you're in the agriculture field, it's going to be a question of, okay, where are your actual crops? But then also, where are you getting your water from? And what could be affecting the space in between that? And so that's the location data that we'd have throughout that area. And then on top of that would be the Earth data, which is what is all the environmental things that are happening there. What is our chance of floods or risks or fire risks, of other extreme weather events and hurricanes? If I have an oil platform, I want to know if the hurricane's coming through, how likely you'd be hitting that platform. And then finally, we have kind of AI as a new level on top of that that's really helping to bridge those two and give us more predictive models on top of that. So when we think of these things, geospatial is critical. But it's always more than an address. So this is an example of a farm. And if I look up the address of the farm, I get basically the farmhouse on that one. And if I were to look at, well, what's the flood risk in this area, I could look at that map around there where we think that it might flood. And if I looked at my individual point, I could say, OK, I'm not worried about flooding. But of course, that's where your house is. That's not where all the farmlands around that are. And so we have to be able to convert that into those polygons around it. And so what SpatiaFi has managed to do is take this massive data set, and I'll speak to where these assets come from, and then take those individual points, which in some cases might be buildings, or it might be fields, or it might be manufacturing, and let's figure out what's the actual polygon or the outline around that. Because when I'm looking at environmental data, that's the piece I need to be comparing it with. And then after I have that outline, I can say, OK, what's the greatest satellite technology, or what's the other greatest gridded maps that I can put on top of that to compare? And then after I have that environmental feed for it, let's give us an API so we can pull that into anything we want to be able to say, for that asset, what's the flood risk? What's the biodiversity of that region? What is the water stress? So when we look at these things, there's kind of 4 major time periods that we have to go across. In order to understand kind of what's the baseline, this idea of historical is really important. Because we have to see, is it always been at this level, or what's the trend starting to do, and what is the shape of that? And so being able to go back through satellite imagery of potentially 30 or 40 years tells a lot of story there. And we have a fair amount of certainty in this column. This second piece is really a current, or what's happening right now. And this is something that often you're not going to get from these models that you might have run historically. And so again, satellite and image processing is going to be really critical. And so now we're stepping into the forecast side, and there's 2 pieces of that. One is kind of the near term, or what I would call operational. I would say investment grade maybe. And this is like 1 to 2 weeks notice. So if I know it's fire season, and I know things are getting a lot hotter in this area, what specifically around that might I want to do differently with my operations? If I was running trains, where would I maybe be really worried about being too close to some other areas that are quite hot, or something else like that? And then finally, these are the longer term projections. And this is the one that I think we've all heard for the longest time, that, where will sea level rise be in 2050, in 2080? And so for some people, it's always this trade-off of what is the use case I'm trying to solve, and where do I want to pull from this timeline? And the other piece that generally comes with this is what's your certainty in that data. And so we're very confident in historical. We're pretty good on current, depending on how old that is. We're starting to forecast. And then uncertainty is going to be at the highest level for these last ones, depending on what we do in between there. And so what SpatiaFi's product does is it brings all these components together to give you the world's largest climate-connected location data sets. And in the earlier one, you saw that we're pulling a lot of this from Dun & Bradstreet, which is a large, one of the largest data sets of where these assets are. So if you are in the United States and you're a federal agency and you're working with this other company, they're required to have a Dun ID. And with that, you can start to get all these underlying assets and where they're located. And then we run kind of all these risks across that and make those available depending on use cases for the annual, the monthly, the weekly, or the daily frequency. And then this is available to you as an API. Because the whole point of this is to tying this into your actual operations. We're not trying to kind of build the perfect UI for everybody, because everybody has a different use case. But how can I bring this into what I'm already looking at today? How do I bring this into kind of my traditional analysis? Or how do I want to be alerted when I'm seeing other things changing? I think we covered that. So just talking a little bit here about the type of examples that we might be able to do. Let's say there is a severe weather event, and your physical assets managed to make it through. So your infrastructure, your facilities, and your equipment have made it through. What else might be affected, though? Well, understanding kind of what are your roads, your rails, your ports, your airports, how do I get products in and out, and how many of those would be affected as well. So understanding how those map out is critical. Also, if I'm looking at this, well, what are the other changes that might be happening? If I look at the increased cost, if it's a large heat wave now, maybe I'm spending a lot more on cooling than I ever did before. So my electricity bill is going way up. Or maybe there's a much larger demand for water because of the lack of things that are happening there. If I'm in the biodiversity or the tourism space, the natural capital loss could be huge. If people are coming in because they want to see these beautiful areas and we have a severe weather event coming through, that's going to shut those down. And so having insight into all of those is really critical to this. And so by mixing these two pieces together, we're getting some views into that aren't captured in your traditional credit risk, which is the business that many of these organizations were in. So I just want to bring two examples before I move on to the next one. Oh, sorry, wrong laptop. So in this case, we're looking at a current or an active fire. And we can see that it's very close to some solar panels around there. So depending on where you are in this chain, I'd be worried about different things. If I'm the land manager for this, maybe that's a timber reserve or something else. And so I have to say, OK, what timber maybe I'm not getting from there? If I'm the person that owns the solar panels that are out there, will that hardware be destroyed? If I'm somebody that gets electricity from that region that's being generated by that, well, a lot of the smoke that's coming out of that's probably coming over those areas and blocking that out. So I'm going to see a drop in it, or maybe they'll be covered with ash for a while, so I need to send somebody out to clean those things. So you can start to see all the things downstream as that works. So we've spoken a little bit here about some of the climate risks and severe weather events. But the next area that SpatiaFi is really pushing it is related to this nature-related financial disclosures. So I want to invite Keiko up to kind of speak to what they've been doing there and where we might be headed.
Thank you, Brian.
Sure.
Well, hello, everyone. It's nice to see familiar faces. So you just heard from Brian that at Climate Engine, we translate and quantify climate-related risks into economic terms of some sort. That's the language that businesses speak, and that's the language they respond. And it's also actionable as well. But what about biodiversity in business? If you are in the earlier session today, this morning, Eric from Ecoregion said climate scientists have their shit together, but biodiversity scientists, they argue among themselves. Well, it's a very difficult area to achieve the results on protection of biodiversity risks. So in this presentation, I want to talk about how businesses are trying to address their impact on nature and why people like you have a very important role to actually reverse this trajectory of biodiversity destruction. I guess this is a slide. Great. So you've probably heard of this very appalling statistics that our economic activity basically wiped out more than 80% of wild mammals and half of all plants. Yet we rely on nature for half of our economic output. Now, this awareness has driven us to set up targets to protect biodiversity. So we do have targets at the global and national levels, But when it comes to specificities, like how to measure biodiversity, well, this is a very difficult question, and there hasn't been an agreed approach. But, oh, there's a wrong. But there are organizations and initiatives trying to answer these very difficult questions. And for businesses, they are called TNFD, Task Force on Nature-Related Financial Disclosures. And they are endorsed by financial institutions and corporations with this specific mandate in mind. Let's assess the nature-related risks by businesses. So let's look at this TNFD. Well, why do they care? Why businesses care about nature? Well, I think what really changed is this shared sense of urgency and crisis, as you saw that staggering statistics in earlier slide. And this is the quote from a co-chair of TNFD: "There is no flow of funds in a dead planet." So there is this momentum among businesses, okay, we need to do something about it. And let's start with the task force. And TNFD was modeled after TCFD, if you have heard of them. So the nature replaced with climate. They started back in 2015, and it's Task Force on Climate-Related Financial Disclosures. And they have achieved quite a bit of success that some countries made it mandatory for large corporations such as UK, Canada, Brazil, Singapore, and actually 35 countries are trying to make TCFD mandatory for companies. Now, that's a great win in working with businesses. But when it comes to TNFD, they just started 2 years ago. And just last month, during the New York Climate Week, they launched the final recommendation that consists of 14 items, what to disclose about their nature dependencies and related risks. And I'm not going to go through all the 14 recommendations, but I want to highlight one, which goes like this: disclose locations of assets or activities that meets the criteria for priority locations. Well, it's locations and location. Remote sensing scientists have been doing this anyway from space, revealing the supply chain and complicated, basically connecting the dots and creating lines. Where are you sourcing your supplies from? And this is a very exciting recommendation for me, even though it sounds simple, because this is based on very strong physical geoscience. You don't have a big room to play around when it comes to lat long. If the lat long falls into a lake, it is a lake. And if it dries up, it did dry up. Maybe there was a depletion. So I have a very strong confidence of this, where the TNFD is going. But this is only a beginning. This particular recommendation comes with loaded guiding scientific questions. And they also provide guidance for companies to answer this question. First, you need to know what is your sector business. Because if you are an IT consulting company, your dependency on nature would be very different compared to companies like in agribusiness. So first, let's make sure what is your sector, what is your business, and that's going to decide what kind of aspect in nature you'd be depending on. And then which biomes and what kind of ecosystem services are you interfacing with? That's the third question. And lastly, make sure if you are or if you are not, your assets are located in ecologically sensitive locations. And they also define what they mean by sensitive locations. Well, are they in an important area for biodiversity in terms of species? Or is the area experiencing rapid decline on ecological integrity? The area has high water stress? Or is it important for ecological service provisions for indigenous and local communities? So these are the questions they need to answer for this one particular recommendation. And businesses, as you can imagine, asked, how can we answer these questions? We are not scientists. So TNFD provided further guidance by giving them actual data sets. For sectors and dependencies, you can look at these. For interface, you can look at these other data sets. And for sensitive locations, biodiversity importance, you can look at them. For rapid decline in integrity and water risk, then ecosystem service provisions. You've probably seen some of these data sets. Maybe you have worked on these data sets if you haven't used. These are amazing data sets. It's a hard work by so many scientists for so many years. But none of these data sets were made with this specific use case in mind. They never expected business going to use it to assess their asset risk using these. So what I mean by this is, in order to use them properly, you need to understand how they were made. Every research and data set has a defined scope and limitations and assumptions. So in order to use them, you do need to understand these details. And that is not an easy task to ask of anyone. And it's not only that, when it comes to rapid decline in integrity, what does that mean if location A says 0.1 and location B says 0.2? Are the differences sizable enough for business to make a decision about not investing in location A, or is it even meaningful? Which score means high, which score means low? Now, these questions are actually very difficult questions, and only people like you can probably help answer these questions. And another difficult question is about attribution of damages and indirect effect on biodiversity, because even you have a boundary of your business location, and let's say there's a boundary of protected areas nearby, your company's impact can go beyond that boundary. Like pollution is a good example. Just because it's not overlapping doesn't mean you don't have an impact. So early example of companies trying to use TNFD, they used distance functions. How far are you from the protected areas, or how far are you from deforested areas? And that proximity they used as an inference as their influence. And by the way, Earth Engine is a great, powerful tool to use distance functions. And I wrote a short example for that book. So if you're interested, please take a look. But my message here is, my concern is that if it's so difficult to navigate through these data sets, we may end up with fewer companies engaging in TNFD. And let alone the dream of making it mandatory. And I think only people who can actually make it more usable and applied would be people like you in this room. So if there's anything you can take away from my presentation, if you are writing a research proposal on biodiversity, and if you are looking to make an impact, TNFD is a great opportunity to make that happen. It is a manifestation of this growing momentum. The businesses should do something about it. As you saw in the first slide, that half of our economic activity depends on nature, yet we wiped out 80% of wild mammals. So working with business is the key, and to make your research really impactful. And I think TNFD is really the manifestation of that, and something I would love for you to consider for your future research. If you're already doing it, please let me know. Let's chat. I would love to hear from you. Yep, that's my message. Thank you.
Hello, everybody. How are you guys doing? Tired? I see a lot of tired faces. So my name's David Saah. I'm a professor at the University of San Francisco, talking about Brian's multiple hats and my bald head. I'm also a principal in an environmental think tank called Spatial Informatics Group. And this is Karis.
Hi, good to meet you, everybody. I'm Karis. I direct our environmental mapping team. So we have a lot of Google Earth Engine specialists on our team, and we work on a variety of thematic issues, and we'll talk more about that.
And one of the things that we wanted to get across today is like, well, how, if you're a professor and you have a company and you're trying to make impact, why are you doing this? What's the purpose of this, right? And it really comes out of a lot of frustrations in terms of the way traditional science is done and how it's actually used. How many of you guys have done traditional research? Everybody. How many of you guys love proposal writing? Not a single one person. God bless you. Right? So when you look at this sort of thing, it takes a long time to get base research out the door, right? Everyone's nodding their heads. I see that. And by the time you get base research out the door, it needs to get applied somehow, and you need to figure out how to translate that base research into applied research. That takes a long time. And then when you look at trying to figure out how to get that applied research into companies like Keiko was talking about, God knows how long that takes, because none of us have a lot of expertise in it. It takes a while for those few examples to actually be able to make that leap. And by the time it gets to a decision maker where you actually have a real action, it takes even longer. That process is a long, long time. And when you look at climate change and climate risk, the theme of this area, this conversation here, we don't have that kind of time, right? Like we need to be able to do this in a more integrated fashion, in a more resilient fashion, in a place where we're able to learn together in an agile way, right? All those data sets, Keiko, that you brought up, that you said, hey, great research, can't really use it, it's not purpose-built. Why? Because those conversations weren't integrated right from the very beginning. There needs to be interlinkages between base research, applied research, operational open solutions, and scale to market levels. Earth Engine and the Google team have been part of that conversation. And if you look at a lot of the infrastructure they're building, they're enabling it. They're enabling it in terms of building out research capacity for that research to actually occur. And the part that's very exciting is that last linkage where they're also enabling it by linking us into corporate conversations where there could be that impact. In places where a traditional research scientist or a traditional think tank can't do that, these programs are allowing us to enable and push that forward. And if you look at each of the different elements, there's engagements along the way. So that goal is to have a fully integrated solution for each of the different questions and iterate and iterate and iterate over and over and over and over and over again for this to work. Now, the next question you're going to have is like, David, you have a bunch of like these academic-y box plot looking things. How the heck does that actually work? I don't believe you. Anybody thinking about that in the back of your mind? I don't see any hands up, but I see some virtual hands up, right? The way it works is it's not one person, one organization. It's all about how do you build an open science platform to make this work. NASA is a great example where they're actually in their research projects and programs really pushing on these open science components, which includes things like open transparent science, open inclusive science, open accessible science, open reproducible science. If that's all real, then those integrations become a lot easier. An example of this, where did this actually occur? Or it occurs in a lot of different places. I want to give you one example that builds on the fire example, and then Karis is going to tip off on the flood examples right afterwards. This was a program that was funded by the California Energy Commission. And the California Energy Commission wanted us to build the next generation of wildfire models. And when I say us, it's a consortium of 18 different organizations really honed in on understanding base research, extreme fire weather, an understanding of fuel loading and what those characteristics look like, an understanding of near-term wildfire forecasts themselves, the 10-day forecast, the one if you looked at Brian's slides, each one of these things fits in some of those boxes, and then the climate change one, the long-term forecast, the 100-year forecast. And how do you build out each of these different elements? Assemble teams of researchers that are able to do this and integrate it. And one of the tools that came out of it is this PyreCast tool, where you're able to track every wildfire in the United States, get a 10-day forecast, updated every 6 hours, freely available, and made accessible to everybody. open science, research, delivered, right? That's great. People are looking at it, but how do you get impact with it? So what we ended up doing is we took that entire ecosystem of analytics and we teamed up with the First Street Foundation in Europe. And the idea behind that was to take the fire hazard expertise that we have, team up with Arab's expertise in terms of engineering and construction. And if you have ideas or measures of fire hazard and vulnerability, you could quantify risk. And if you think about the risk itself, you could think about the risks not only today, but you could think of risk with climate change 30 years from now. So you're trying to hone in on people's most valuable asset, their homes, using a financial instrument that's connected to their most expensive financial obligation, their loan, which is typically at the same scale that you would have for climate change. This is great. Base research, applied research into some sort of operation. And what ends up happening is that we're able to deliver a fire risk score for every property updated every year for both now and 30 years from now, where you're actually making those values meaningful to that individual, right?
I'll just say my house almost flooded this summer, and I went to this tool. So he's talking about fire, but there's other risk factors. I was like, what's the 500-year mark on my property? It's cool for like all of us.
Yeah, and so if you go to like Redfin or Realtor.com or Zillow, you'll see this information getting pushed out. There's also a press release where Freddie Mac is partnered up with the First Street Foundation to be able to integrate this information into their information streams. Right, so now you know that little graph that I had that showed the integration of base research, applied research, operations, scalable? It works. Now, that's great. What happens when we have the next generation of learning? Do you think we got this right on the first time? No, we kind of sucked. Right? There's some things that don't work out very well. So what we ended up learning is that, hey, there's new IPCC models that we want to integrate. Let's integrate them. We know that some of the pyromes, our fire sheds weren't, the fire distribution doesn't match up with our observations. Let's calibrate them. Let's figure out ways to incorporate suppression in these fire models in ways that are meaningful. And then let's also fix the building stuff. Let's fix the architecture stuff. And as soon as you do that in that integrated fashion, you don't have to go and distribute it to each of the different organizations. It becomes a learning that lifts all of us up at the same time, right? And what happens then is that it gets picked up by other organizations. So for example, this data is now, the White House is using it on the EPA online climate risk tools. Right? Do you see how that works? In order to scale this stuff, we need to kind of change the way we think about things. It can't be built in individual units. We need to think about modularizing our understanding and our learning and start thinking about the way that we interconnect these things. Do you want to talk about this stuff?
Yeah.
Okay.
So, fire hazard example is super cool. It's like a long process. If you're sitting in the audience and you're like, I have this one little, specific deep dive knowledge domain or something tech, like a cool tech piece I've developed, how do I integrate that into this huge network? I loved the talk from Global Fish, Tim, yesterday. One conversation 10 years ago, and look where that, brings you. How do we bring that conversation into something that's a huge network, building these huge data sets, institutions, getting the uptake? So I'm going to show you, these are a bunch of microservice solutions that the Severe networks have been building. And I'm going to talk through some different pathways on how you can integrate microservices, build microservices, and get them into the hands of users. So the first one, pathway on existing data. So if you're out there, you're building your own data sets, you get them into the marketplace. That's one way to make a huge impact. Again, like Global Fish Watch or the JRC data set. Or if you are working with different data decision makers, you can just run some analysis on these existing data sets that are already processed for you. So in this case here this is in Myanmar, we have a historical flood analysis tool. It's compiling all the information from the JRC water frequency data set and just displaying this for decision makers to understand what is the historical risk in my area. Second pathway, for those of you working with near real-time data, getting information out quickly, processing Landsat, Sentinel, some of the raw imagery sources, integrating that and making that available is the second pathway. So this is one example we have is in Philippines and Cambodia. We have near real-time forest disturbance alerts. At that point, we were working with groups that needed information, seeing underneath the clouds. So this is a radar image time series. Processed data set, providing near real-time information. When we released this, other SAR-based alerts were released. So how do we network, how do we use all of that data to build out stronger decision-making? Which brings me to pathway 3. How do we integrate data? How do we integrate processing that other teams are doing? How do we collaborate on this? So in the example with our near real-time alerts, we took our alerts, piped them into a system, and we took the other near real-time alerts, the GLAD alerts, all the Global Forest Watch alerts, to kind of build out this ensemble approach. And then we linked it with another team. For those of you that were in the Collectorth Online session yesterday, we took some validation tools that another team had developed to make it easy for, in this case, park rangers working in Cambodia or in the Philippines to get those mapped alerts, and before they send people into the field, where it's expensive to get them in the field, time-consuming, we pipe those alerts, the hotspots, into this simple-to-use platform with high resolution in the background, and we made it kind of like we thought of the Tinder swipe function, like, is this deforestation? Nope. Is this deforestation? Yes. So you can swipe it back and forth, and when you say yes, it goes to the ranger, and they can go act in the field. So this is one example of I have all of these data sets. Other people are making similar data sets and cool tools to act on it. How do we bridge those conversations to link your data, your tools, your networks with people on the ground to go make a really big impact? So this is an example. We didn't end up doing the swipe function, which is boring. Is this deforestation? Yes, no. We'll work on the swipe function next. Who wants to collaborate? And then the final service. So in this case, we have, I brought you to here. So the validation alert. Up here, we get the activity on the ground. Rangers are going out there. We have other teams that are wondering, we have all these alerts coming out and we have extra information on the communities. How can I think about integrating these services, these data sets, across the disciplinary teams to think about, community vulnerability, community hazards, et cetera, et cetera. So I think the pathway forward, to me, is the most exciting. We can build all these microservices, is what we're calling them, but starting to think about how we can connect these, how we connect all this disciplinary information to build kind of that richer narrative for decision making. And now I'm going to hand it over to Dave to talk about how do you build these teams.
Yeah, exactly. No, thank you, Karis. Just taking one step back, just to make sure we get this thing imprinted in people's brains. Each one of those little boxes you could think of as we were calling a microservice, an API that's built on open science, open tools, open analytics, completely transparent. And the goal behind that is that you want to give people the trust and the ability. You want to give people the trust in the analytic and the ability to improve any one of the different elements. And then as you start constructing different configurations of it, as one section improves, the whole system improves, right? That's a goal, right? And that's been our general approach with our Google Earth Engine partnerships with our corporate client interactions, because we want to get folks the stuff that they need when they need it using the most honest and transparent information we can get them. And in order to do that, it's a co-development process. What we're finding is that folks really want to be engaged in the conversation. Some folks want the click and run sort of thing. They say that, but when you start getting them more involved in these sorts of things, they want to understand what's actually there. And so what we've done there is we've learned a lot from the Severe program. The Severe program has been pretty amazing in the code development cycle, where you actually have meaningful engagement with that end user right from the very beginning. You identify the problem from the very beginning. You go through those microservices conversation with folks. You co-develop that solution in ways that are meaningful to them. I remember in one of the rooms we were talking about integrating indigenous knowledge. Well, not everybody has all those sorts of expertise. How do we pull that group and that microservice into this sort of thing? Once you actually have a configuration lined up, you test it together. You look to see where there's impact, and where there's impact, great, you run it. When there's no impact, or you missed the mark, you go through the process again. And when there's new opportunities, new learnings, you go through the cycle over and over and over again until you get to that desired impact. The other thing to think about when you're building out these products and when you're building out these solutions for folks is future-proofing it, right? How do you future-proof this to make sure you don't have a gap in science? How do you future-proof this so you don't have a gap in accessibility, right? How do you future-proof this so you don't have a gap in the way society changes its priorities or needs, right? There needs to be a lot of flexibility. There needs to be a lot of openness. There needs to be the ability to collaborate in large-scale, meaningful ways. And the Earth Engine cloud configuration, the way that is currently being designed and being adjusted, is quickly adapting to that. And we're finding that as we continue to have conversations in the research community, folks are very excited about it. And as we translate those conversations into the private sector with private sector folks that want to actually engage in this, they're very excited about it. And those conversations are leading to a lot more things in the future. All right.